Moving on to the second session on blockchain and cryptocurrency, Dr.V.Panchami, Head of the Department, CSE Cyber Security, Indian Institute of Information Technology, Kottayam. She is the founder of Cyber Labs IIT, Kottayam. She is the principal investigator of funded research and consultancy works and presented more than 20 research articles in various SEI Scopus indexed journals. Her research areas are lightweight cryptography, authentication schemes, blockchain and cryptocurrency, quantum safe, post-quantum cryptography, network security. And she is serving as a reviewer for various international and national journals. She got NASCOM Award for the Ladies Safety Act and received Best Research Paper Award in various conferences. On behalf of the organizing committee, WAIMS 2022, we welcome you, ma'am, and the session is yours.
Thank you, and good morning all, and thank you for the introduction. Hope you can see my PPT, right?
Yes, ma'am.
Yeah, and it is moving as well. Slides are changing. Is it so?
Yes, ma'am.
Okay, thank you. I'm Panchami. I'm from the Cybersecurity Department of Indian Institute of Information Technology, Kottayam. So today we are going to discuss about the blockchain technology and cryptocurrency. So before going to the blockchain technology, let's see what's the need of these kinds of technology in the current perspective. So I am all through my lectures, I am explaining the blockchain technology in terms of financial application. So particularly speaking, the cryptocurrency. Okay. So let's start and. One second. I want to connect my gadget, that's why. Yeah. So hope I am audible to you, right? Okay. So so first of all, we have to discuss about what's the need of the blockchain technology. So you can see as per the figure, so there is a centralized approach and we call it as a decentralized approach. Over the rightmost is the decentralized approach, and where we are saying about, we are starting with the centralized approach, what we are exactly doing to transfer some amount of money from a person who is in a particular country and wants to transfer the money towards another person in another country. Okay, so in this case, say this is Alice and if it is Bob, And if Alice want to transfer some amount of money, it could be in dollars or in Indian rupee, or even in the cryptocurrency, whatever it is, she could uh, she could need a third party, so that this third party is a financial institution. Normally we say bank, right? So she need a financial institution, so that she want to transfer the amount, and the financial institution will transfer the amount towards that particular recipient. Okay, so in that case, if you are sending some, say, $10 or some other cryptocurrency or even normal currencies of a particular country, so here a particular percentage should be there for uh, the transfer fee, right? So the transaction fee. So a particular percentage of amount should be enabled by this third party or this financial institution as the part of the transaction fee. So there will be, the first thing is that there will be high transaction fee in the current scenario when you try to transfer the some amount. So inter transfer or the inter money transferring between the countries and all. And moreover, it may take one day or even days, not weeks exactly. Now it's just take days in order to transfer, or at least minimum one day to transfer your money to, or minimum 1 hour, okay, or 2 hours to transfer your money from a particular country to another. Okay, so that's a one point, but the main point I want to emphasize here is that high transaction fee will be there, so that this whatever the verification or whatever the service offered by this financial institution, they enable a high transaction fee. So that's the first point. The second point is that double spending. Double spending is the scenario in which if a particular party is trying to send a money, okay, the same amount of money at the same time to different persons. Okay, so in as you know that we are in the digital era and we are using our Paytm or n number of applications in order to send the money. Okay, so the double spending could be happen because of nowadays because of an digital error. It could be intentional or unintentional. Unintentional means if you are trying to buy something, or if you're trying to so transfer the money, you may, okay, because of the poor internet, you sometimes go for double tapping the button, right? So when you go for double tapping the button, twice your money will be deducted from your account. So that chances are still over there. Okay, double spending is there. Okay, and so it could be because of unintentional, intentional methods. So in the current scenario, double spending problem is existing in our money transfer problem. Okay, it's in our money transfer. The third point is that network frauds. So network frauds, even if we are coming with the blockchain technology or the current existing technologies or the current existing infrastructure, the network frauds are there, because the network frauds because you are getting n number of mails or calls or messages saying that you have to share your credentials to the third party. So never ever share your credentials to a third party. So that so this is the very limited or very very limited kind of attacks. There are severe attacks are there in terms of security of these systems. Okay, you either the network, the frauds, the hackers or the crackers get the database. They can they will get your database from this centralized party, so that all the details with respect to the clients they will get. As a result, your money will be lost, right? So network fraud activities are there in a very extensive manner in the existing technology, and it will be there in whenever we go for the blockchain technology. But what are the measures that we are taking in the blockchain technology in order to make it tamper-proof or immutable? That's the main point. Okay, so network frauds are there. Poor data recovery means if it's a centralized approach, right? For example, they may be using a server or a multiple servers, or even they are getting some backups are there. Okay, so if something happens to your data, okay, and say as I said, intentionally or unintentionally your data is being deleted, what happens if you want to get your data? So you have to request your third party, right? It's your data and you are requesting to the third party saying that I need the data. So it may take weeks and months in order to get back your deleted data. So they have to go to their backup storage, then retrieval should be there, and number of documentation process should be there to get your data. So it will be taking, in order to get your own data, it may takes days or weeks or months, right? So poor data recovery is the one of the disadvantage of the centralized approach. So this is known as the money transfer problem. Money transfer problem in the existing financial transaction. So I said earlier, this we are explaining the blockchain technology need in terms of money, right? So otherwise, instead of money, any item you can transfer with the help of this technology. It could be kerosene, it could be anything or any item you could transfer from one party to another. Okay, so however we are explaining in terms of cryptocurrency or in the financial sector. So this is the money transfer problem, and we are saying that when we enable this blockchain technology, this will be, we can completely wipe, or we can't completely solve these problems, but we can solve this problem in terms of high transaction fee. The transaction fee is, we could say that, cheap. Okay, it's very cheap. Cheap in the sense, it's all, even though we are switching to the blockchain technology, these are all business, right? They need money. Okay, so so we can't claim that there is no transaction fee, as of course transaction fee is there, but when comparatively it is cheaper. Okay, so it is cheaper. Then there is no transaction fee. Okay, so the transaction fee is much cheaper than what we are facing nowadays in a centralized approach. That's the first point. The second point is that double spending we can completely wipe out. Okay, so when we implement blockchain, the double spending can't be possible. The third point, network frauds. Yes, network frauds are there. We can't avoid them, or they come up with different tools, different techniques. They are very smart people, so they try to tamper the data or the database, right? So in blockchain technology, while we are implementing the blockchain technology as part of the transaction, we can say that it's a very secure database, so that the immutability can be achieved through the blockchain technology. So network frauds are there, but we can claim that the data are immutable. Whatever the data we are storing in the blockchain technology, it is immutable. Okay. So poor data recovery, as you see over here, there is no centralized approach. There is no centralized approach. Like all the data are being stored at the peer side. Okay, that means your data as well as to whom you are interacting with, and all the data are being stored in your side. So there is a completely decentralized approach when it comes to blockchain technology. Okay. So whenever we heard, like in 2008, Satoshi Nakamoto, he introduced, we don't know whether he or she, however it's an anonymous researcher, he come up with a peer-to-peer cryptocurrency. It is called blockchain. So after 2008, people start discussing over this particular white paper. It is spreading across the internet. In 2009, the real blockchain, the real Bitcoin was implemented. So after coming with the Bitcoin, the people start asking about, or people start discussion about what's the technology behind this Bitcoin, the digital or the cryptocurrency. So the technology behind the digital currency is the blockchain technology. Then people start thinking over, or start working with respect to the blockchain technology. Then they have started using this blockchain technology to n number of applications like supply chain or medical management systems. So wherever you need a secure database, you can easily replace with your normal database, and thereby you can come up with immutability as well as verifiability is very much high in the blockchain. Okay. So the second point is that does the Bitcoin and blockchain technology is same? No, Bitcoin is just a cryptocurrency, right? It's a digital currency that you could send your money from a particular person who is sitting in different parts in this world, so that they can transfer their money with minimum transaction fee through a decentralized manner. So if you want to transfer these currencies, so of course security should be enabled, as well as there should be some kind of technology, right? So a technology should be needed for moving your digital asset from one individual to another. That technology, we call it as blockchain technology. So what do you, the blockchain technology, that means if you want to, this definition is completely depends upon the financial sector. Okay, so the technology that enables the moving your digital asset. Okay, so digital asset, here our digital asset is the coins, right? The digital currency from one individual to another. So that's the technology. So blockchain technology is the technology which enables to moving your digital asset from one individual to another, while the Bitcoin is a cryptocurrency. So in that sense, we can say that blockchain is not Bitcoin. Okay, blockchain is not just the cryptocurrency. You can address the blockchain technology in different other applications. Okay, apart from this cryptocurrency, it could be any item you could transfer from one person to another, so that you can achieve verifiability at each and every point, as well as you can your data will be immutable. Okay. So next I have to emphasize over here that what's the definition of the blockchain technology? It's a cryptographically secure. It's a cryptographically secure open distributive ledger, right? So it is cryptographically secure open distributive ledger. So let's debug one by one. So this concept we can divide into one part, and the other part we will discuss. Okay. So we can move towards that. We are saying that the blockchain technology is open distributive ledger, right? So let's have explanation for that. It should be open. First, we can say it's an open ledger. Okay, ledger means what? It's a transaction, right? So the transactions are stored in as the ledgers, right? For example, open means, say these are all the peers who are in the network. Say this is Alice, and it could be Bob, Catherine, or the Daniel. So these are the peers in the network where Alice is holding some, say, not dollars, we could say some Bitcoin. Okay, so say 10 Bitcoin. Alice is holding how much Bitcoin? It is 10 Bitcoin. It's even if you go for the dollars itself, yeah, there is no problem for that. Okay, so whichever the blockchain you are using, it could be converted into that perspective cryptocurrency. So you can input or you can give dollars, and your system will convert it into what kind of platform if you are using. For example, if you are using Ethereum, it could be converted into Ethers, or if you are using Polygon, it's converted into Polygon itself. Okay, so however it is, we can say that a person, Alice, is holding how much Bitcoin? 10 Bitcoin. It will be stored, how much Alice is holding, it will be stored as ledgers. Okay, Alice is, so it is open. Open means Alice, Bob, Catherine, Daniel, all the parties who is in the network can see how much Alice is holding. So as the next part, Alice want to send some 5 Bitcoins to Bob. Okay, so what happens? The first point is that every party who is in the network want to verify whether it is a valid transaction or not. So whether it is a valid transaction or not. Here, validity is checking on a basic concept, but in a real scenario, validity is checking with respect to, we are using cryptographic approach, where n number of approaches are some data structure we have to use. Okay, so using n number of technologies, we are checking the validity of a particular transaction. But in this case, our aim is to explain what is open ledger, right? So the validity we can check in a very simple manner. For example, see, if you have 10 Bitcoin with you, you can easily spend 5, right? So you have enough and more money to spend 5 Bitcoin to borrow. So in that sense, it's a valid transaction. But in a real scenario, the validity is checked with respect to data structure approaches are there, networking approach is there, as well as the mainly cryptographic approaches are there in order to check the validity of a transaction. Okay, so Alice want to send Bob how many Bitcoin? 5 Bitcoin. So if the transaction is valid one, okay, it will be the part of the ledger. So as it is open, because A, B, C as well as D can view the ledger, open ledger. So if we want to send some, say, 3 Bitcoin, so it is valid, right? Because B is already holding 5. Out of 5, Bob can easily spend 3. So as it is valid, it will be the part of the chain, open ledger. Okay, and this ledger, you can see it is in a chained manner, right? It is connected with each other. So or it is connected with the previous transaction. Is it so? So 3. So for example, if Catherine want to send some 10 Bitcoin, does it be the part of the open ledger? Does it be the part of the open ledger? No, right? Because Catherine doesn't have that much to spend. So this transaction won't be the part of this open ledger. So this is the open ledger. Next, we are going towards the distributive approach. Open distributive approach. The distributive means there is no central open ledger over here. Instead of that, this open ledger is distributed across all the peers in the network. So it will be stored by stored in the node, okay, of A, B, C as well as D. Now it becomes open distributive ledger. Okay, so that means your data will be holded by yourself. Not only your data, whoever participating in the whole chain, you can see that data. So it's everything is open, so that the transparency is very high in while you implement blockchain in applications. Okay, verifiability is also there, because if somebody do some kind of fraud things, at the same time, all the peers in the network can verify that it is a fraud activity. As a result, B will be out from this network. Okay, so this is the open distributive ledger. Now about the cryptographically secure. How it is cryptographically secure, we will explain in a very very detailed manner, okay, in the coming slide. So hope you have understand what is open distributive ledger. So here, when it comes to open distributive ledger, there is a problem. What will be the problem over here? There will be synchronization problem. So that means all the parties want to maintain the same open and distributive ledger, right? So, or all the parties in the network want to share the same ledger among themselves in the network. So how the synchronization problem is solved, that we will explain after 2-3 PPT. Okay, after some 2-3 PPT, or after dealing with the basic of the blockchain technology, we will come again and deals with how the synchronization problem is solved. Okay, so synchronization problem is or will be there when it comes to open distributed ledger. Next is, as I said, blockchain is a immutable, or it would be a distributed public database of immutable records. We call it as blocks. So you can see that it is a distributed, very secure database. Your data could be stored in the blockchain, right? So how the term called blockchain? So we have the blocks. Blocks is a record book. Block is a record book. For example, what the block consists of? Block have a block number, a nouns value. It is quite interesting. Okay, so the nouns value, it is a random number. So that we will discuss in a very detailed manner. Okay, so it's a random number generated for each block. So block number, a random number is there. Nouns, the data. Here our data is transaction data, right? Transaction data. In a particular block, not only one transaction data, you can accommodate multiple transaction data or multiple transactions. You can accommodate n transactions in a block. Then a previous hash is there. So previous hash, as this is the previous hash, means if we are creating our first block, this block is known as Genesis block. Okay, so for the Genesis block, there is no previous blocks are available, right? So that the previous hash will be all zeros. Previous hash will be all zeros, not 4 zeros. It's actually, I will explain you. Okay, so however, the previous, as there is no previous blocks are available for the Genesis block, the previous hash according to the Genesis block will be all zeros. Okay, so we have a hash function. Yeah, so we have a hash function, particularly SHA-256, hash function 256 function. That means you will input, you have to concatenate this data, this data, this data, plus the previous hash. The whole thing will be given to a hash function, so that some hash is being generated. Some hash is being generated. Okay, so you can see some peculiarity for this particular hash. For this particular hash, yes, of course, when you go for any hashing, you can see that some alphanumeric values are being generated. But for this particular hash, you can see some zeros are in front of this hash, right? So that's a peculiarity of a block hash, and it is generated as part of the mining. Okay, so however, as a first point, I want to emphasize a block consists of, what are the items in the block? A block number, nouns, it's the random number, and the n number of transactions, the previous hash, and it is given to a hash function, so that some hash is being generated. A peculiar kind of hash is being generated. Okay, so that's a block. And what about the chain? These blocks are interlinked, right? So how it is being chained? Okay, so let's see. So this is the Genesis block. What are the inputs? The block number, right? The nouns value, n transactions, then the previous hash, this one. So it will be given to a hash function, SHA-256, particularly speaking. In Bitcoin, we are using the SHA-256. It will generate hash code. Okay, it will generate a hash code. And this hash code, okay, this hash code will be the previous hash of the next block. In that way, we are saying it is interlinked. So according to block 2, what are the inputs? Block number, it is 2. There will be a nouns value, okay, and again there will be n transaction. And what about the previous hash? Previous hash is the previous hash of the block 1. Okay, the previous hash according to the block 2, the previous hash means the hash of the block 1. So in that manner, it is being interlinked. So according to block 3, so block number, nouns, then n transaction, and according to block 3, the previous hash means the hash of the block 2, right? So in that way, it is interlinked. So we can say that the blockchain is a distributed public database of immutable records. So how it is immutable, we will explain. I will explain. And so immutable record, called blocks, and these blocks are interlinked, right? Using the concept of previous hashes. Okay, so next is we will discuss about mining. And next, I want to emphasize a point that so if Alice want to, so we will in a nutshell, I could say that if Alice want to transfer some, say 10 Bitcoin to Bob, what Alice will do is that Alice will generate a block. So while Alice will generate a block, what are the block inputs? Block number, nouns, the end transaction, then the previous hash. It is creating a block, but this block is an or invalidated block. Okay, it's not valid. It's not valid block. Not valid block means once you create a block which is not validated, you can't get a hash like this. You will get some random alphanumeric value. So when you go for running the hash functions, you will get random number of alphanumeric values, right? So in that way, you will get a block having a hash of random number of alphanumeric values, but not exactly you don't get a hash like this if it is not a valid block. Okay, so now it is not a valid block. This block is being broadcast towards all the nodes in the network. Okay, this all the nodes in the network, so that once receiving this invalid block or the not validated block, so all the nodes in the network will receive this invalid block, right? Upon receiving this invalid block, there are some special kind of nodes. We call it as miners. Okay, so all of us can be the part of the network, but there are some special kind of nodes or users. We call it as miners. Why they are special? Because if we want to become a miner, we need enough and more computing power. Okay, so enough and more computing power, we have to invest time. Okay. And so what the miners will do is that miners, so according to miners want to find a nouns for a particular block. For example, if this is the block 4 and it is not validated, so the miner want to find out a particular nouns of block 4 so that it generate a particular target value. So there will be a target value, and the miners has to find a particular hash in such a way that the generated hash is less than or equal to this target value. So what approach they are actually implementing? They are implementing the brute force kind of approach. Brute force means the trial and error method. So they come up with nouns 1 or one value, 2 value. So upon they will increment at all. So theory says that within 10 minutes a transaction is going to, or within 10 minutes Alice could transfer money to Bob, or we can say that within 10 minutes Bob will receive money from Alice. So the whole scenario should happen within that 10 minutes. Okay, so within that 10 minutes the miner has to input around 60.25 quadrillion nouns in order to find a exact hash which is less than or equal to the target value. So the target value is a hash it's a hash, but some zeros are in front of this target value. So the miners have to find the particular nouns of a non-validated block so that there will be a target value. The miners has to find a hash function which is less than or equal to target value. That is the cryptographic puzzle that the miners want to undergo. So if you want to play, or if you want to be the part of the mining process, you need enough and more computing power with you. Okay, so Alice will create a block. It is not validated. It is shared among the peers in the network. Once upon receiving these non-validated block, the miners will start mining. So if a miner come up with a particular answer, or if a miner or miners will compete among themselves in such a way that if a miner come up with a successful answer, then the miner will get a reward of 6.25 Bitcoin. So around Bitcoin costs between 16 lakh to 18 lakhs in Indian rupees, today's price. Okay. So around 6.25 Bitcoins these miners will get. That means the miners will get, if the miners successfully done the cryptographic puzzle, they will get a monitorial benefit. Okay, they will get a monitorial benefit. As a result, not only the monitorial benefit, the miner who has done the cryptographic puzzle successfully, they can validate this block. I said validation is done by some cryptographic approach. So they can validate the block, whether it is a valid one, whether this block is generated by Alice. So some kind of validation is done, or validation check could be done by the miners. So once the validation is done and it is successful, miners will add the new block to the existing chain. So the chain is with the miner itself, right? So whatever the chain that he is holding, he can add the newly validated block to the existing chain. Then there comes the synchronization problem. So in order to solve the synchronization problem, the miner has to broadcast the newly generated or the new or updated blockchain towards all the peers in the network. In that way, we can solve the synchronization problem. As a result, Bob will receive 10 Bitcoin. The whole procedure will happen within 10 minutes. On an average of 10 minutes, the money will be received by the party or the receiver, wherever he is sitting in this world. Okay, so Alice will generate a block. It is not validated block. The block will be broadcasted to all the peers in the network. Among these peers, there are some special kind of nodes. We call it as miners, who could capable of validating the block. So if you want to validate the block, they want to undergo for a cryptographic puzzle. They have to won that puzzle. If they have won the puzzle, they will get a monitorial benefit around 6.25 Bitcoin, and they can add, they can validate the new block. They can add the new block as the part of the existing chain. So in order to solve the synchronization problem, that particular miner want to broadcast the chain towards all the peers in the network. So this is the way in which a transaction is done with the help of blockchain technology. Okay. So next we have to discuss about the cryptography, how it is cryptographically secure. What are the technology that support to make it immutable and secure, right? So as I said, one of the approach is that, for example, say if I am tampering this particular block, okay, if I am going to tamper this block, or tamper means I am changing the data in the block, what happens? The hash will change, right? This hash will change. But you could see that the next block will be storing some other hash value. So as a result, when we compare these two hashes, it is not going to match. So not only, if you try to tamper the data, not only this block, the whole chain, the whole remaining chain becomes invalid. So in that way, we can say that it is immutable, but there are different perspective, or there are different layers in order to make it immutable. Okay, so I will show you a blockchain demo. Yeah, I hope you can see the screen, right?
Yes, ma'am.
Yeah, so this is the blockchain demo. So this is a SHA-256 algorithm. So I am inputting some value. So as you can see that while I am inputting each and every character, the hash is being changed, right? So it is being changed. And you could see that whenever I enter a single character or multiple characters, some fixed length of value is being generated. So that's the one of the properties of the hash function, where it is a one-way function. Okay, so the one-way function means upon receiving this hash code, you can't generate what exactly the data is. So you can input varying length of message, so that the hash code remains fixed. Okay, so this is your data, this is the hash code. So when you input the varying length data, the hash code is remain fixed. So now we move to the block concept. Okay, so block, you can see the data whatever we have discussed. Okay, here we have a single data, single input. Here the point is the data could be split into three categories: the block number, nouns, and the data. So once the data is, there is no data over here, however it is given to a SHA-256, so the hash is being generated. So now I am going to tamper the data. Okay, what happens is it's something, it becomes pinkish, right? So that means it's a tampered block, or it's an invalid block. Okay, so if it is tampered, you could see the hash, right? Can you see the hash? The hash is some random alphanumeric value. So when you create, or if you are saying that if a block is a invalid block or not validated block, you will get you are generating a block hash, but the block hash is something a alphanumeric value. Okay, so if you want to make it is a valid block, you want to go for mining. Just click on the mining. So it will take few seconds. So yeah, now it becomes a valid block. Now you could see that the hash is being changed, right? So what's the specialty of this hash? Some zeros are in front of this alphanumeric value. Is it so? That means if the number of zeros in the hash increases, as a miner, the complexity of finding the nouns is also increases. Okay, so the hardness of finding the nouns will increase when the number of zeros in front of this hash function will increase, or it is directly proportional. Okay, so we have to set, or the network itself have to set the target value in such a way that it is not too hard, or it is not too easy, so that on an average of 10 minutes, a miner could find out the nouns, the appropriate nouns. This is the mining. So instead of the single data, when it comes to block, we have multiple points, right? Multiple data, block number, nouns, data. Okay, so next is we can come up with a chain, block chain. How it becomes chain? Because the previous hash is being added to the part of the block. Okay, as you can see, this is the genesis block. That means this is the first block. For the first block, the previous hash is all zeros, and there is a nouns, and you can see the hash. Some zeros are in front of this hash, so it is a valid block. Similarly, if you want to become a chain, the block 2, according to block 2 will hold a previous hash. That means the hash of the block 1, right? So you can see the previous hash of block 2 is same as the hash of the block 1, 001578, right? 001578. So this is the way in which we are making the block as a chain. So there comes the block chain. So now let's see, if I tamper the data, what happens? If I tampered the second block, not only the second block, the entire chain becomes invalid, right? Invalid. So the next point is that you can overcome this particular tampering. How? Because you as a researcher, we are assuming that not as a researcher, in a normal scenario, we are assuming that the adversary has enormous power. He has enormous computing power. He can invest that much of time. So in that scenario, if even though he tampered his block, he can do, if he have enough and more computing power, then he can went for mining. Okay, he can go for mining. So if he can go for mining, what happens? For mining, it needs computational power. So there is a lot of cost associated with mining. So if the adversary have enough and more computing power, even though he tamper a particular block, once he went through the mining process once again, you can convert it into a valid block. So now the tampering is successful, right? Is it so? Yeah. So then what's the next step? So similarly, if you want to make it, if an adversary, want to change these all invalid block, then every invalid block he want to went through the mining. So it is very costlier approach, very costlier in terms of time processing. Okay, and the probability of doing this is very less within that time period. Okay, so however, there are chances that this is also possible, where if you try to tamper, if the adversary has enough and more processing power with him, he can make it a valid chain, right? Yeah, so you can see that I have tampered this data. Okay, I have tampered this data, even if it becomes a valid chain. Is it so? So is it tampering is possible? Then it comes to the distributive approach. So there comes the distributive approach relays, where the same chain, right? You can see that the same chain is stored in different peers, right? Whoever participating in the network, like peer A, peer B, peer C, everybody is holding the same chain, right? So if a particular peer tamper his data, what happens? The whole chain becomes invalid. Okay, so he has enough and more computing power with him, so that he can come up with a valid block. So even though he has tampered the block 2, he come up with a valid block. Similarly, the mining is done with all the blocks. Yeah. So he has successfully tampered the data, and he have validated all the blocks. But comes the distributive approach, and this distributive approach make it really immutable, even though the adversary has enough and more computing power. Here you can see that none of the peers in the network is going to accept your newly chain, or whatever the chain you have formed. Okay, so none of the peers won't accept your newly formed chain, because you can see that according to block 2, the hash is around 00717, right? But what the hash, the block peer B is holding some 0012FA. What about C? The C is holding the same block 0012FA. So that means none of the peers, because of this distributive approach, even though you try to tamper or you are successful in a particular attack, your chain is not at all going to exist. So none of the peers in the network will accept your newly formed chain. As a result, the whole transaction, that being the part of the chain, becomes invalid. So that's the way in which we are claiming that your chain, or the blockchain, the data in the blockchain is immutable. Hope you have clearly understand the idea. So now we can move towards the cryptographic features of the chain, or how it is cryptographically secure, right? So cryptographically secure is done with SHA-256. A digital signature is used. In order to come up with the digital signature, a public asymmetric approach is there, proof of work mechanism, and the mining process. Altogether, while deploying different kinds of cryptographic concepts, we are saying that it is the blockchain is cryptographically secure. So it is the SHA-256. We have already explained about that. And these are the properties of SHA in such a way that for a particular, it's a one-way function, right? If you are inputting X, it will generate H of X of H. So anybody who received this H won't get this X, right? So it is infeasible to generate X given H, right? The small h. So it's a one-way function, and collision resistance means if you are inputting x1, so that it will generate h1. If you are inputting x2, it will generate h2. So there won't be any two messages. There won't exist any two messages in such a way that these two messages gives the same hash. So it won't. This scenario won't be we can't tolerate this scenario in terms of SHA. In that way, we can say that the hash value is a unique identifier for your message. It's a unique identifier for your message. So none of other messages like M1 to Mn gives you the same hash when you input M of M. Okay. So in that way, this hash function is applied in blockchain technology in order to identify each and every block uniquely. So we can say that this hash will be a unique identifier for a particular block. Okay, so these are the few hash properties. Next is about one more property I want to emphasize here is you may heard about avalanche effect, right? Avalanche effect means here the input is Fox. So that if you input Fox or this input or the third input, you will get a fixed alphanumeric value, right? Fixed sized alphanumeric value, but it is completely permuted manner, right? So the point is that just assume the second input and the third input. Just compare between. What's the difference? There is only a difference in a character. Even though there is a single character is being changed, if you compare the output, the whole alphanumeric values is completely non-linearly permuted, right? It's completely, there is no comparison. We can't compare between the two outputs of two hash codes in which if you input two different messages, even though these messages a single character is being changed. Okay, so this property is known as avalanche effect. It could be applicable for your encryption function as well as the hash function. That means if you flip a single bit, here we have a character. That means according to your processor, it could be normally represented as 4-bit, right? So here we are flipping 4 bits, right? So the point is that avalanche effect says that if you flip a single bit in the input, more than 50% of the output bit has to be changed. That character should be there in your hash function. This property should be in your hash function as well as in your encryption functions as well. This property should be satisfied. Okay. Next is the digital signature. As I said, there should be some kind of verification, right? So some verification is done by each and every node, especially the miners, so that the node is being the part of the chain, right? So some verification is done. The verification is done in the Bitcoin with the help of elliptic curve based digital signature algorithm. Elliptic curve based digital signature algorithm. What it is doing is your data. Here our data is transaction data is given to a SHA-256 so that it will generate a hash code. So this hash code is given to an encryption function. Here we are using asymmetric encryption. Asymmetric encryption means suppose this is Alice and it is Bob. Alice has two keys, public key of Alice and private key of Alice. Similarly, Bob also have public key of Bob and the private key of Bob. So asymmetric says that if you encrypt it with a particular key, decryption is only done with the other key pair, right? So let's see how it is being applied in the digital signature. So the transaction data is given to the hash code. So the hash code is given to an encryption function. So it's an LT curve function. And for the LT curve function, the hash code is one input. Another input is the Alice private key. The Alice private key is only known to herself, right? So that the digital signature of this particular data is being generated. So this is the digital signature data. So what Alice will do? Alice will broadcast the data plus her digital signature plus her public key, because these nodes are not known to each other. So she will broadcast the message, the digital data, the digital signature. Okay, message is in terms of block. Okay, actually it is in the terms of block. Then the digital signature plus her public key. So these three things will be received by all the nodes in the network. So every node in the network can validate whether this block belongs to Alice or not. This is one part of validation. Okay. So how the validation is done? With the help of the digital signature, electrical digital signature. What happens is that the Bob will receive the data. From the data, it is given to a hash function, the same hash function, so that the Bob will generate the hash code. So this hash code, okay, it's on the one hand. On the other hand, the digital signature is decrypted with the public key of Alice. So it is decrypted with the public key of Alice. The public key is given and it is decrypted, so that the hash code is being generated, right? If the hash code is matching, okay, the generated hash code and the received hash code is matching, then each and every peer in the network can verify that this block is generated by Alice itself. Okay, and for verification, we are using the LTCR digital signature algorithm. Okay, so apart from these hashes, the digital signature, we have another one. This is the consensus algorithm. Consensus algorithm used in the Bitcoin network. It is the proof of work consensus algorithm. For each chain, they have their own consensus algorithm. In Bitcoin network, we are using the proof of work consensus algorithm. So what exactly the consensus algorithm? It is we have already discussed that there is a cryptographic puzzle that each miner has to undergo. That cryptographic puzzle is known as the proof of work, right? So proof of work is the process to determine a nouns. Okay, so it's a process of determine a nouns, so that while inputting the block number, the nouns, the transaction data, it will generate a hash code. This hash code will be compared with a target value. If it is lesser or equal to this target value, the miner will won the cryptographic puzzle. So each miners will undergo through a cryptographic puzzle, or particularly speaking, a proof of work mechanism, so that the miner will get a reward if they are successful, or they will get a monetary benefit, as well as they can add new block to they can verify the block, as well as they can add the new validated block to the existing chain. So this is the miner. So what kind of approach the miner will take? Miner will take the trial and error method or the brute force method, so that within 10 minutes the miners want to input around 20.6 quadrillion nouns. That much of hectic it is. Okay, so miner should have some process, very good machines with him or her. Okay, so that he or she can act as a miner. So this is the way. So the miner want to find out. So a block number will be there, a nouns value n1, the transactions, n transactions, and the previous hash. So you have a software with you. Okay, if you want to be really take part in the mining process. So in that software, you just want to input the nouns value. so that it will generate a hash. This hash will be compared with the target value. So target value something looks like some alphanumeric value. In front of the alphanumeric value, there will be some zeros in front of that. Okay, so as the number of zeros increases, the finding of this non-value will be heavy, or the hardness to find this particular nouns will be increasing when we increase the number of zeros in front of this target value. So the target value and the generated hash value is compared. If it is less than or equal to, yeah, okay. If it is less than or equal to this target value, then we will claim that yeah, so the cryptographic puzzle is he has won the cryptographic puzzle, and he can add the new transaction. He can validate the new block, and he can add the block as the part of the chain. Okay. So this whole process is known as the mining process. Once a miner has done the mining, so the miner will get a 6.25 Bitcoin, and so the amount will be reduced to half every 4 years. Okay, so after 4 years, it is again reduced. Okay, so that's all for a brief introduction about the crypto blockchain and the cryptocurrency. If you have any kind of queries or some communications with me, you can communicate over cyberlabs at IIIT kottayam.ac.in. Thank you all.
Any queries from the participants, sir?